question B, we're given a rational function f of x that is a g of x function in the numerator and an h of x function in the denominator. It says we get a quotient of 3x plus 4 when we divide these two functions, remainder of plus 8. The denominator is a linear function x minus 2 and g of x is a quadratic polynomial. So we're being given a bunch of information that we need to interpret. So first of all, we're going to look at the quotient. The quotient of this division, when we do this long division, the quotient will end up being the slant asymptote. So we have a 3x plus 4 as our slant asymptote. So I'm just going to sketch that in. We have 3x plus 4 here. The remainder, I'm going to go to the h of x function. So the h of x function represents the denominator, so this represents our vertical asymptote at plus 2. So at x equals 2, we have our vertical asymptote. So g of x being a quadratic just means it's being consistent that a quadratic divided by linear function is going to give us a linear quotient. And we've been given some other information here that the remainder is plus 8. Well, the remainder of plus 8 is redundant information that we can get this information from other places, but it indicates that with a positive remainder, we're going to have it along this positive diagonal. So we know the function must be in this area here. We can also determine this by the other parts of information. It says that g of 1 is equal to 0. That means that at x equals 1, we have a 0 of that function. And at g of 0, we get 0. So again, here is our other root. So we have 2 points there. So we know the graph must follow this part here, must follow the asymptotes and go through the zeros. And we know that the other part of the graph must go through here. Okay, we don't have a lot of details, but the details that we do have, we can come up with this part of the graph. We can come up with the slant asymptote, the vertical asymptote, the points of interest, and also the quadrants that we're going to draw this graph in.